Very good morning. Today we're going to see a problem on Chebyshev type 1 filter. The problem is like this: design an analog low pass filter, that too with the help of Chebyshev type 1 technique, that has -3 dB and upper cutoff frequency of 100 radians per second and a stop band attenuation of 25 dB or greater. This is not ARE, this is OR or greater for all radian frequencies which is more than 250 radians per second. So now based on this, I'm going to write a magnitude frequency response of a normalized Chebyshev filter, or in general. Now first I'm going to represent magnitude frequency response of a Chebyshev filter for a given specification. So y-axis represents magnitude, x-axis frequency. So if you look here, they have given -3 dB and upper cutoff frequency of this. So let me consider Kp as -3 dB. Corresponding to that, I have upper cutoff frequency. In some cases, now they will give this as passband frequency only. Okay, in some textbooks, if you observe, you'll get almost the same specification, but instead of upper cutoff frequency, they'll mention it as passband frequency. Anyway, because this is passband region only, right? So both are one and the same, which is 100 radians per second. Along with that, they have given us stop band attenuation, which is 25 dB. Here I have written the same, and stop band frequency corresponding to that, the frequency is omega s dash in general, and that is equal to 250 radians per second. Now I know formulas only to design that particular filter wherein omega p is equal to 1 radians per second. In other words, if omega p is equal to omega c is equal to 1 radians per second, it is known as normalized filter. I don't know, to design any other filter. So in general, I'm going to consider this magnitude frequency response. So if you observe here, this is y-axis, which represents magnitude, x-axis frequency. This is 20 log magnitude h of j omega axis, and this is only omega axis. Okay, this is not this omega. This is the, you need to consider it as this omega. Okay, fine. So Kp, Ks values will remain same. That is -3 dB and -25 dB. Omega p, since it is normalized, it is 1 radians per second, and omega s value. So this we don't know. Okay, we need to find out that. How to find out that particular value? So we have studied A to A transformation, right? That is analog to analog transformation. I have clearly mentioned that suppose if they gave you this, if I want this, that is normalized filter, if I want specifications I need, and if they have given you this specification, then how I can convert it? That can be converted with help of this particular equation, that is backward difference equation, which is given by omega s is equal to omega s dash by omega u. So have they given you omega u as well as omega s dash, which is upper cutoff frequency, and another frequency which is corresponding to stop band gain? Yes, of course, they have given you this particular values. So you can make use of this particular formula, that is omega s is given by omega s dash by omega u. As I already mentioned, in some cases they'll mention it as omega p. Both are one and the same. In that case, your omega s formula will become omega s dash by omega p. So if you substitute to that, you'll get omega s. As a result, you'll get all the specifications that is needed for us to design a normalized filter, wherein omega p is equal to 1 radians per second. Kp, Ks value will not change. Only thing is I need to know this particular value. So I'll use this particular logic so that I can convert now this specification into normalized one. Anyway, omega p is equal to 1 radians per second. Omega s is given by this, that is omega s dash by omega u. In some cases, omega u is considered as omega p. Okay, at that time, this here you need to do one change, that is instead of omega u, write it as omega p. So what is omega s dash? 250 radians per second. What is omega u? 100 radians per second. Divide that, you will get 2.5 radians per second. That will be a value for omega s. Now once you get all the specification that is needed in case of a normalized magnitude frequency response, you can proceed with the design. That is, we can obtain transfer function through which we can say that we have designed a desired filter. Now, what is the first step in designing a filter? The first step is to find out order of a filter. In case of Chebyshev filter, order of filter is given by n greater than or equal to cos hyperbolic inverse 1 by d by cos hyperbolic inverse 1 by k, this particular equation. Do I know the value of d and k? Where d is discrimination factor, k is selectivity factor. Have they given you this data? No. So it needs to be found out. How? D is given by this particular equation. D is equal to under the root 1 minus del p whole power minus 2 minus 1 divided by del power minus s minus 1. Again, do I know the values for del p and del s? No, I don't know, right? So I need to find out it. So in last class I have used separate equation for del p in order to find out del p. This time I am using one more formula wherein you can easily find out the value for del p. So kp is given by 20 log of 1 minus del p, because this value is known, right, which is which will appear in magnitude frequency response of a filter, and if you apply 20 log for it, you will get kp. Now we have already understood this as a part of a theory when we discussed theoretical concepts behind Chebyshev filter. So I'll use the same concept to find out del p. So we are using this, you find out del p, so you'll get del p like this. Similarly, last class also we used the same, right? Ks is given by 20 log del s. From that you can easily find out del s. Once you find out del s and del p, you can find out discrimination factor. So substitute the value of del p, substitute the value of del s, which was obtained through this equation, okay, and then you will get the value of d. So once you get d, which is other quantity we need, which is k, which is known as selectivity factor, which is given by omega p by omega s. We know omega p, we need to consider it as 1 radians per second, because we are designing which filter? Normalized filter, right? If it is normalized, omega p is always 1 radians per second, because we know formula only to design normalized filter. Omega s you just found out, right? Just 2.5. So substitute that, you will get the value of k. Once you get the value of k as well as d, substitute that back in the expression for n, which is given by cos hyperbolic inverse 1 by d by cos hyperbolic inverse 1 by k. You will get n as greater than or equal to 2.27. As I already mentioned, order of filter cannot be a decimal number, so you need to consider it as next highest integer, which is 3. Fine. So we'll proceed. You know that once you find out order of filter, next step is to find out pole. So if you want to find out poles, you need two constants. If you can remember which are they are a and b. If you want to find out a and b, you need to know the value of epsilon. So I'm going to find out the value of epsilon now. So you know that del p is given by 1 minus 1 by under the root 1 minus epsilon square. If you simplify this, you will get epsilon square like this. That is, epsilon square is equal to minus 1 plus 1 by 1 plus del p whole square. Okay. So if you use this particular equation, you will get epsilon square like this, and then from that you can easily find out the value for epsilon, so which is needed for us to find out poles. So once you find out order of filter, the next step is to find out poles. The formula for finding out poles in case of Chebyshev filter is this, that is sigma k, or in other words sk is equal to sigma k plus j into omega k, where k varies from where to where? 1 to 2n. This is very, very important, you need to remember this. So out of what is the value of n here? N is 3. So k will vary from 1 to 6. Out of this, we need to consider only first half, right? The reason is we are designing a stable filter. If you want to design a stable filter, we need to consider those poles which will appear in left half, right? So we'll consider only first 3 values of k, which are 1, 2, and 3. Again, sigma k is given by minus a sine 2k minus 1 into pi by 2n, and omega k is given by b cos 2k minus 1 into pi by 2n, and a and b are constants, which is given by a is equal to half times 1 plus under the root 1 plus epsilon square by epsilon whole power 1 by n minus 1 plus under the root 1 plus epsilon square epsilon whole power minus 1 by n. So if you do one change, you will get the formula for b, that is instead of minus you replace it as plus. So we have already found out the values of epsilon. Substitute that, you will get the value of A as 0.2986 and the value of B as 1.0435. So once you get the value of A and B, so we can make use of that here to find out sigma k and omega k for various values of k. Those values are 1, 2 and 3. So for the first value of k, now if you substitute that, you will get sigma k as 0.1493 and omega k will get it as 0.9036, and for second value of k, you will get sigma k as 0.2986 and omega k will get it as 0. So you need to use this particular formula. Okay, substitute that in this as well as in these equations. Definitely you'll get back the same answer. And then similarly for the next value of k, you will get it as sigma k as minus 0.1493 and omega k will get it as minus 0.9036. Now once you get the values of pole, so what is the pole here? So it is combination of this with this, right? That is S1 is equal to minus 0.1493 plus 0.9036 j, because Sk is given by sigma k plus j into omega k. And the next pole is S2 is equal to minus 2986, that's it. And S3 is equal to minus 0.1493 plus into minus, it's minus only, minus 0.9036 j. Clear? Next, once you know, first step is to find out order. We found out order, which is 3, and corresponding to order we'll find out poles, and we have found out poles, and then we'll proceed with finding out the transfer function. So here Hn of S in case of Chebyshev filter is given by Kn divided by summation left of poles S minus Sk, whereas in Butterworth filter you don't have this particular one, right? This particular term is not there. It is just 1 by summation left of poles S minus Sk. That is the only change which you can make out here in finding out transfer function. So Kn divided by, now how many values, what is the value of order? It's 3. So you'll get 3 values of k, as I already mentioned, because we are designing a stable system. So we'll consider only those poles which will appear in left of. So it has been found that first 3 values will appear in left of. So I'll consider only those 3 poles. As a result, I'll get S minus S1, S minus S2, S minus S3, Kn divided by, right? So we already discussed the poles. We'll substitute that. So that you will get S plus 0.1493 minus J 0.9036. Similarly, S plus 0.2986 into S plus 0.1493 plus J 0.9036. Now simplify this. You can consider it as A plus B into A minus B, which will give you A square minus B square, right? And then this I'll return as it is. Further, this can be expanded as A plus B whole square is given by A square plus B square plus 2AB. And then expand this, j square is minus 1 into minus 1, it will become plus. So here you will get it as plus, and you retain this as it is. Further, you multiply this with this, you will get this, and then further simplify, you will get this answer. That is this answer. You will get it as this. Now, what is the value of Kn? The value of Kn depends whether n is odd or even. If n is odd, the value of Kn is always equal to B0. What is B0 then? Bn is the last value of the polynomial, which is always a constant value, right? This one, that is 0.2502, etc., right? So replace this value by this particular constant term, which is B0, which represents B0, right? Which is a constant. You will get only one constant, so that will be B0. And if n is odd, the value of Kn is B0. In this case, since n is odd, it is equal to this particular constant. Okay, so I'll replace Kn by this particular value. As a result, you will get this. Since n is odd, Kn is equal to B0, which is 0.2502. I'll substitute that. Okay, you will get H3 of S, which is normalized Chebyshev filter for order n is equal to 3. But is the value of omega p is equal to 1 radians per second as per my specification? No, right? It is something else. So what I need to do then? So my specification is this, right? But we found out expression for this. So if you want to convert this into this, then I should use this particular transformation, that is S has to be replaced by S by omega u. If you consider this as omega u, it is omega u. In some textbook, as I already mentioned, they'll give this value as omega p. If they give you this as omega p, then S has to be replaced by S by omega p. Okay. So if you want to get a desired filter, then this, in this expression, that is if I want to get H of S, then H3 of S, this in this expression, in this transfer function, S has to be replaced by S by omega u. What's the value of omega u? If you recollect, as per the equation, omega u or omega p is equal to 100 radians per second. So what is the meaning of this? In this equation, S has to be replaced by S by 100. So I'm going to do the same. So I don't do any change with respect to numerator. I'll substitute or replace S by 100 whole cube plus 0.5972 S by 100 whole square. Similarly, 0.9273 S by 100 and this constant. Okay, further simplify that. Finally, you will get back this equation, which is your final answer. Hope you have understood. Now read this question. Same, right? Design a low pass Chebyshev filter that meets the following specification: pass band attenuation. Again, there they have mentioned just attenuation, which is -3 dB. Pass band frequency, I clearly told, right? Instead of upper cutoff frequencies, in some textbook they'll give it as pass band frequency. And stop band attenuation 25 dB. Even though they don't give this as negative, you should treat it as negative, which is general rule which we already discussed. And stop band frequency 250 radians per second. So hope you can understand the changes that what you are making out in problem 3. Both are one and the same. Only thing is the way they represent, either with help of pass band frequency or with help of upper cutoff frequency, that is only change, right? Terms are differing here. So thank you.